Hello guys, welcome to the AireplayNG video series last part. In this part we are going to demonstrate the remaining attack vectors. In previous two videos we have seen how AireplayNG works, what are the filter options, what are the replay options, and few attack vectors like deauth, fake authentication and interactive attack. It actually sends ARP request and replay frames. Now first of all, why to do this ARP replay attack? ARP replay attack will be very handy attack because ARP request is bound to get a reply. If we actually re-inject the ARP requests again and again, AP is going to resend those packets on wired side, and the wired host is going to reply with ARP reply, and AP is going to replay that packet on wireless side, and lots of packets can be easily generated with the help of ARP request kind of packet. Second important thing with ARP request is a fixed length packet, so it is easy to figure out which is the ARP packet with the help of simple length filters. Let's see one quick demo of ARP replay, and then we will see how exactly these packets will be used to crack the web key. So this thing will be AireplayNG -38880. It will keep on prompting what all other parameters I have to give. I have to give BSSID, as it has no knowledge that which packets it has to filter. So it is also asking me for host MAC, as it should know. Now it is actually capturing the ARP packets. It is saving those ARP packets in some cap file. It is a PCAP, standard PCAP file, and it is asking me to start AireplayNG to capture the replies, because unless I capture the replies, I will not be getting lots and lots of new IVs. Unfortunately, currently no ARP requests are seen. Currently a ping is going on. Let me stop the ping, let me clear the ARP cache of my client, and let me restart the ping. And it has sent the ARP request as expected. Since ARP cache was cleared, it has resent the ARP entry, and it has captured those ARP requests, and now lots and lots of packets are being generated. Now if simultaneously I would have started AireplayNG, I would have captured those ARP requests and replies with different IVs, and then those packets have to be given as the input to AireplayNG to crack the web key. If AirCrack PTW is used, even better, even faster, around few thousands of packets are enough to crack the web key. Let's stop it. Let's move on to next attack vector. It is chop attack. Now chop attack is actually discovered by Corex. What exactly is done in chop attack? To understand that, we should first know how web packets are encrypted and how ICV is generated. Now for creating web packets, actually we have the key, we have the initialization vector. With the help of key and initialization vector, key stream is found out. Now the actual unencrypted packet is XORed with the key stream to get the encrypted packet. The ICV is calculated. ICV is simple CRC32 function, and it is placed at the end of the packet. A property of CRC32 function is it is cumulative. Being a cumulative, if we can change single byte of the calculating vector, we can easily recalculate the ICV. This is the fundamental behind the chop attack. Now what exactly chop attack does? Chop attack will change every byte. Every byte will be changed from all possible combinations. So it will be start with 00, 01, 02, 03 to FF. For every combination of for every byte, the ICV will be recalculated, it will be recomputed, the packet will be sent into the air. Now why such packets, or how to find out which packet is correct packet? Very interesting question. These packets will be sent with destination MAC as some multicast MAC. Now multicast packets, for every multicast packet, AP has to relay this multicast packet on wireless side as well. Now AP will only relay those multicast packets which are encrypted correctly with the proper ICV. Now I will be able to guess the correct byte in the packet only if that packet is replayed by the AP. So all those packets which are replayed by the AP on wireless side are the correct packets. That is, the byte in that packet is the correct byte, because the checksum of that packet will match. If you want to know more about this chop-chop attack and the mathematics behind this chop-chop attack, you are requested to search on securitytube.net. I will be creating one mathematical video of this chop-chop attack. Let me start it. I don't want to select this packet. Let me select this packet for replay because it is from my host and it is sent to my AP. It is now actually going on changing every byte of the packet, and it is sending that packet on air, and it is looking for the response from the AP. If response is got from the AP, it is proceeding to the next packet. Likewise, it is doing the thing for every packet. It is showing the XOR value. It is showing how many frames were actually required to get the correct value and how many seconds required for that. Okay, now it will keep on doing this. With the chop-chop attack, we will not be able to actually get the web key, but we will be able to see the decrypted packet, and it has done. Wow, it has actually decrypted the packet with correct value in 54 seconds. Okay, now let's open this packet. It has actually saved this packet in plain text and keystream. It has saved the plain text in this file replay, I'm sorry, dec-0516.cap. Let me open Wireshark, and cool, it has actually decrypted the packet. See, this is the echo ping request going from some MAC to another MAC, and I'll be actually able to see the details of the packet. These are the headers. This is LLC header and this is ICMP header. This is ICMP header. So with the help of AireplayNG chop-chop attack, we will be able to actually decrypt the attack, decrypt the packet. The help of fragmentation attack, will not be able to get the web key actually, but we will be able to get the key stream, and with the help of key stream, once we got the key stream, we can actually inject any packet that we need onto the wireless interface. Since key stream is tightly tied with the initialization vector, we can easily generate the packets with that particular initialization vector with that key stream. That's it for this video. Here I have explained on all the attack vectors AireplayNG can use to assist the process of web cracking. With the help of AireplayNG, we can actually enhance the speed of the web cracking, and the cracking process will be very fast. Thank you. Feel free to give feedback about this video and for other videos on securitytube.net. How actually web keys are getting cracked. You are welcome to see the video of AireplayNG and other suite of products. Thank you.